Cool. Welcome back. Have a bit of a submission hangover. Like, just got through one thing, on to the next. It's a good time to like recoup and what did I learn here? What did I demonstrate? And then immediately, like, how can I use this? At least that's the design around these. Like, homework, take a while, then project, do the project, just get it done. And so as far as like schedule coming up, I guess we could look at like month, even though the month calendar drives me crazy. Yeah. All right, so here today we're on Spooky Friday the 13th. And on Tuesday, goal is submit that project 1. So take everything we discussed and kind of worked on in homework 1, apply it to project 1 today, Monday. And then Wednesday, I won't be on campus. Kind of good news, my brother's getting married on Tuesday night, so pretty exciting. But I won't be here on Wednesday, so we'll have today, Monday, and then Wednesday take like an actual break from the class, and then Friday we can be back working on the next module. Sound like a plan? Cool. Have you broken anything yet? Anything like fun to work on for the project? No? Reproducing bugs and error message decoding. That's the good stuff. Let's get like a mix of art and skill for programming. Bad while loop? Yeah. That'll happen. While loops. So there are some programming languages don't have while loops, because you can always create a for loop that has like an unlimited number, like just give a for loop 1 million steps with a case of saying like, if you find the right answer, stop it. And for me, I always find that's better, because like, why would I want, I guess the only time that I'd want a while loop is like if I'm making a game, like, and I want the game to just keep going no matter what until you actually hit like cancel the program, like stop everything. But anyway, that's just me. I don't use while loops in general, because like, why? Yeah. Do you know how to stop something if it's just running forever? No? That's a good skill to have. Nice. Yep. So there's always like every interactive development environment or even like command line, there's always something to stop the code. But if I just make like a while true print cool beans, this is not going to be cool beans, because it's just going to keep printing cool beans, and it's never ever ever going to stop. So it's like, all right, well, I need to stop this thing. There's a little stop button at the top. Stop the thing. So that's always good. Whenever you like, especially if you're like timing things, like you're trying to figure out like how long did this take to run. Something takes like 1 second to run, and you run it 1,000 times, you're going to be sitting there staring at it for a while. So use that little stop button up in the top, and that's the Jupyter way of just like, forget what I told you, just stop what you're doing. Let me check in, see what people are working on, and then we'll go from there. Yeah.
Question. I've started module 2.
Oh, okay. Nice.
So just at the very beginning, but system kind of ahead is where did we download your CSV data file? So where is it pulling this from essentially?
That one is in a folder. So if you click, if you want to see like the structure,
Yeah.
file, and then open, and then it'll show you like this. So this is your current working directory.
Yeah.
So you click on that one. Oh yeah, that one down, like one up, and then inside data, there's a bunch of data that we can use.
Gotcha. So this is where it's all stored.
Yeah.
And we pulled this from the repository originally, or no? Separate.
No, this is just
what was built in.
because we have that tool in the envelope, it grabs everything. It is in your repository.
Yep.
In that same folder though.
Okay, and what the heck is it?
That one is a Linux command that lets you look at the first and like any number of lines of a file.
Okay.
So by default it's 10 lines.
And the bang, the exclamation point?
That is letting you get into the system commands. Because normally it's all Python commands.
Okay.
Bang operator. Or I believe Python do something and then come back.
Perfect. And it's pulling this down to begin with because now it's going up a folder from where we are currently.
Yeah.
And then it says from within this higher level folder going into data.
Yeah.
Okay.
And like Linux and Windows, DOS operating, they both use dot to say like this is the current thing, and then where it's currently working, dot one up.
So
you
if
could go
this was
like
housed in the same folder, it would just be dot forward or backslash your CSV.
Exactly.
Okay.
Yeah. Okay. Yeah.
We're gonna take most of this and then we're trying to figure out what actually did. Like,
Yeah.
so not much of it. So,
Comments, docstring, behind, see yourself.
I know it's the first one.
That's okay. Yeah.
Like reading and understanding and forward and what how you guys do.
Yeah. Oh yeah, I already have some stuff written up. You don't have to. You can use like as long as it's consistent units. Yeah, 45 minutes in hours. You can use minutes if you want. But I'm just clearing out my work a little bit.
Yeah. So, what do you do like add units to the EP?
Sorry, what's that?
Suppose like units to -6.6.
Oh, so right now, at least the way that this derivative is calculated would be like a delta temperature. So you can call it C or K, they're both the same. Like delta degrees divided by hours. So this is the slope of that change in temperature, -6 degrees per hour. Or 6 2/3, yeah.
Pretty sure I could. Budget. But actually, I'm pretty sure let's just. 25 days. I'm done with this. No, this no, it's not. If all of them are in the software, you should be worried. I would want my sponsor to. Yeah. So you want to answer that, or where is it? Oh, let's take a Wayman drive in. You got 3333337.
Did you?
Yeah.
Yeah, I think we have to use one because
I agree.
Oh yeah, you can just yeah. Download is like the actual handle solution.
Yeah, 100 hours. Bless you.
thank you.
I think so. This is more the library. I use that really a lot. Yeah.
Say a calculating temperature change. Nothing good.
I say it's supposed to find yeah.
But we don't have a function. And that's the basic numerical is an actual use this number and we can a function that helps to compare
It's just a right from so let's see what we want about it.
yeah, you set up the remote control
two points.
Actually, yeah, I'll be down to go for this.
Hamburger.
Yeah. Just let them up for a second. It's probably big enough.
All right, cool. So we started, as I was walking around, we started having bits and pieces of this conversation about when I have these two data points. So I don't have like an actual measured slope along here, but I do have a governing equation that there should be some kind of like constant heat transfer coefficient and temperature minus ambient temperature. That's roughly governing how quickly the body is losing heat. And because I have 2 points, I can draw a line through them. Well, I mean, I could if I could actually draw. And that line has a slope. Like there's no other slope that I can calculate with those 2 points. So my left-hand side is fixed. Like that one is just that negative 6.7, right? So when I calculate K and I divide that negative 6.7 by T minus TA, what T do I use? Do I use 85 degrees? Do I use 80 degrees? So right now I know that K is going to be 6.7 over T minus TA. But what is T? What is at 11:45? Why is that? That one's current. Okay. What do you think? Is there any reason to use 11 a.m., the 85 degrees? Why is that?
Because that's what we use to calculate the K.
Right? Yeah, we started there and used a slope to get forward. So technically, at least if we're following like what we had been using for Euler integration, that you would say my current temperature is 0, my slope is describing the next temperature. Both of them are fine, like whether you consider it's called a forward difference or a backward difference. Let's copy this. So one of them I'm saying that current time would be like 85, and I want to subtract, or sorry, current temperature is 80, and I want to use the previous temperature to figure out what is the slope. That's like backwards difference versus forward difference, which is saying current time is 0, use the next one to calculate slope. They're both going to be wrong for like different reasons, but they both have the same like amount of wrongness to them, because we are taking an exact change in temperature per time, like a calculus derivative, and turning it into just, we can approximate it with a slope. So both K's will be wrong, but equally wrong in different directions.
Only because we already did the actual programming.
Yeah.
So you gotta do that.
What's the actual log function? Log base E. What's the log base? This year is this class.
Yeah, so the first one is kind of hard to tell you outside of functions. The second one actually made functions where you can plug in values on it.
This guy's so cool. Oh my god, this is
My music goes into high. Okay, I'll start capitalizing more things. I am about to do that. I'm trying twice at the same time.
It's up to you. Yeah.
So I did it where
Yeah, down the factor. So units are always like important in general, but they become especially important when you're dealing with like real physical measurements and computer code. Yeah.
what you have up there showing a negative K value, shouldn't it be positive?
Yeah, what did I do? Oh,
Because the case negative.
yeah, and K is negative. T1 minus T0. That should be, yeah, that one's negative. Yeah, so it's just that I didn't have. But when I have this result, 1/3 what? What are my units? What am I dealing with here? Or negative 1/3, yeah.
Drop 1/3 of a degree every hour.
So 1/3 per hour? Is that 1/3 of a degree per hour? Is that my units for this? No. Yeah, something else, right? What are the units here? So let's do a quick unit analysis.
Is this gonna be like 1/over?
Yeah.
1/minute?
Yeah.
Something like 1/. Yeah. Okay. So this is like degrees per, if we call it degrees per hour. Degrees, and I think it's Fahrenheit, yeah. And then this is degrees Fahrenheit. So overall, I have a 1/hour. Because the degrees Fahrenheit cancel out and it becomes like a time constant sort of thing, like something per hour. Something's happening per hour, not so much that the temperature is changing that much per hour, but the unitless changes are 1/hour. But if I change this to 45, like just leave it in minutes. That's a very different result, and the result is exactly the same. It's just now I'm looking at 1/minutes. My time constant's in minutes. So when I set up my independent variable, if I have a time constant that's measured in 1/minutes, and I'm trying to set up time going from 0 to 3 hours, I need 0 to 180 minutes. it's not 0 to 3.
So I understand the slope is negative, but is the actual k value a negative number? Or is it a positive number and there's a negative attached to it in the equation?
K is a positive number in general. I don't think there'd be any heat transfer with negative K values. But the general term is always, for the most part, dT dt is always a negative K something. Yeah. I had a friend in grad school who never worried about plus or minus signs, and his reasoning was that if you make enough plus minus mistakes, they all cancel out. And like, yeah, but you always need an even number of mistakes to get it to the right answer. He's like, yeah, usually that's the case. Half the time that's the case. I'm like, okay, yeah. And then people were asking, like, does this number look right? Like, yeah, it looks right. It has decimal places. It exists. So I'm just printing out at least the two results that I had gotten if I'm looking at like 1 over hour, where you can divide by 60 and get like 1 per minute. Yeah. Depending on, one of them's forward, one of them's backward.
Your dt, your derivative is looking backwards.
I changed the step 1 to 20. It's good because it shows that it doesn't keep going. It's going to have some stick. No need to decrease it. Stick. That's still you can It's just solving for formula integration. It's just a way of integration.
How is that in oil integration?
You can use
No, but the oil integration I was doing was today.
but then
sure they're not out. You say that. Curious about your example. It's crazy. It's the same that Boston. Yeah.
You just oh yeah, so right there where you have your S, delete the S. Dash.
So what you have as your blue anyway, you don't think your blue arrow, I think that's the.
That's easy.
Yeah. Easy is good. Easy.
And then
Microphone that we're gonna use. I know, we don't have like an ET and a sparkle.
I think we're both temperature and
Fine, we'll do it like this.
Yeah. Same as
I know how to use
it's just now instead
Didn't
of
know you was
calculation,
what she was
we're looking at temperature. Okay. Got it.
What is this?
It puts out. I don't think so. If you can add too much.
This is just like the analytical solution. Yeah.
How can I access just the title? For the same update based on whatever.
I think it's like if you have a frame, a data frame called data.
Yeah.
Data COLS.
Yeah. And then and you can just slice it based on what column you want.
Yeah, and you could grab like bracket column. Yeah.
Okay.
There's also because once you
Chose the X value.
in there, you know the first two letters, and then you can start matching tabs.
Is it indexed the
Right,
same
it
way the
still
columns?
works.
As in, so is the first column 0?
Yeah. But pandas,
I didn't realize it.
if you want to like index it by like zeros and ones, like that, because it turned it into like one big kind of array. So if you want to get like 0, 0, the very first row, the very first column, I think you use that. And that lets you plug in like ignore the headers and the rows. Gotcha. Specific things. Some people love pandas and other people like hate it. They just can't stand how obtuse it gets. Where's this backward? But I just defined it. Oh. All right, so I'm taking forward difference and backward difference k values, plugging them in. Which one is which? When I actually get like something in here. Which one's the forward difference? Which one's backward difference? Which line is which? I colored them both in blue so we could like use other knowledge to figure out which one is which. What do you think? Top or bottom? Which one? Yeah.
Bottom would be the forward difference.
Maybe forward on the bottom? Something like that. So what are they both start at the same temperature, right? They're both starting at 85. Where are they supposed to go when they get to 45 minutes? It should be 80, right? So at 45 minutes, like right here, that should be our answer, but it's not. One of them is still too hot, the other one is too cold. So which one? But they both, one of them says this is my slope, like that the slope was there, and the other one said that like that's my slope, right? Forward versus backward. So roughly, I would agree like this bottom line is probably that forward difference because the slope is what it started at the very beginning versus like the slope matches at the last time. Does that kind of roughly sort of make sense? Just kind of visualizing what's happening there. Or we can take forward versus backward, like where is the slope, the right slope? We'll do backwards is like green. So backward was like that top line, forward the bottom line. Both wrong by a little bit. If that bothers you, if it's keeping you up at night, you can always take. Can always split the difference, right? Take the mean, calculate both, take the mean, and now it's slightly better. Slightly closer to what we wanted. Cool. Thanks a lot. Oh, I guess we're a couple minutes over, but thanks a lot. Come back on Monday, try to finish up. Thanks. You too.